Hi everyone, today's lesson is called Multiplication of Polynomials. Our goal by the end is going to be able to distribute this monomial into this binomial and distribute this monomial into that trinomial, multiply these two binomials, and more examples. But before we can do any of that, we're going to need to review multiplication rules. What to do when I multiply 2x times 4x. Don't do these examples just yet. I've set aside some other ones to practice first. These next problems that we are going to do, you do not have to write them down. I would just watch and make sure you understand the concept first. Okay, so to multiply exponents with like bases, the rule is to multiply the coefficients and keep the base the same while adding the exponents. So let's look at example number 1. We have variable x to the third and x to the seventh. Coefficients are numbers that sit right in front of that variable. There's no coefficient, so there's nothing to multiply. I mean, if you want, you can see it as 1 and 1. So 1 times 1 is 1. That would be this part. Multiply the coefficients. Keep the base. What do I mean by base? Say I have the number 2 to the third. 2 is considered the base, where 3 is considered the exponent. So the base over here is x, the exponent is 3. The base is x, exponent is 3. So you keep the base, which is x, add the exponents, which make 10. Okay, example number 2. Multiply the coefficients. So my coefficients are 2 and 3. So we multiply those, it gives you 6. And then we keep the base, that's the same, the base is x, and I add those exponents. So 4 plus 5 makes 9. Okay, example number 3, multiply the coefficients, negative 6 and positive 4, which makes negative 24. And now we take the x's and we keep the base and add the exponents. Well, there's an exponent of 2 here, but what's the exponent here? You should be telling me 1. So now when we add them, we get 3. Okay, example number 4. 10x parentheses 6xy. Parentheses are the same thing as saying multiply. So we're going to do the same concept. We're going to take the coefficients, the 10 and the 6, and we're going to multiply them. That gives us 60. Now in this case, we have x's and y's. So we're going to take this x and multiply it with that x. They both have powers of 1. So I keep the x, add the powers to get squared, and then we just tack on the y that's next to it. There's nothing to combine it with, so it just gets added on. Okay? Number 5. The coefficient here is negative 3. What's the coefficient in front of this xy? You should be telling me 1. So what's negative 3 times 1? The answer, put a 1 here, is negative 3. Now we take the x's. We've got an x squared and an x. The x has a power of 1, so I have x to the third. I have 2 here, 1 here. You add them, you get 3. Now let's do the same thing for the y's. Keep the y. Here is a y squared. This power is missing. Power is a 1. So this becomes y to the third. All right. Last but not least, number 6, the coefficient here is negative 10. No coefficient over here but 1, so negative 10 times 1 is negative 10. Take the a's. I've got 1a, or a to the first, and a to the third, which becomes a to the fourth. And there's no b's to combine with, so I just tack on the b. Okay, so remember, the rule is multiply coefficients, keep the base, and add the exponents. Okay, now I think you're ready for some practice. Why don't you try to complete these 8 questions? Pause the video, try the 8 questions, and then resume to see your answers. Okay, take a look. These should be your 8 answers. If you have any questions on these, please circle the ones that you got wrong and we'll go over them tomorrow in class. Okay, now I think we are ready to do some distributing. So let's look at example number 1. I want to take 3x squared and multiply it to this binomial. The way that we're going to do that is by distributing this term into the 9x to the third and distribute it into the 2x. And by distributing, we're multiplying. So let's take 3x squared and multiply it by 9x to the third. Well, the first thing that we do is multiply the coefficients. So 3 times 9 is 27. Now we're going to multiply x squared and x to the third. You multiply those and you get x to the fifth because you add the exponents. So now we've multiplied this and this. Now we're going to multiply 3x squared by a positive 2x. So 3 times 2 gives us 6, or a positive 6. And x squared here, and x multiplied to give me x to the third. Because there's a power of 1 here, and we have to add them. Okay, let's try example number 2. We're going to distribute the 3x into all 3 terms of that trinomial. So let's do the first one. 3x times 9x to the 7th. You should be saying 27x to the 8th. That's a power of 1, so you add them. Now we're going to do 3x times 2x. You multiply those and you get a positive 6x squared. Then you're going to take 3x times 1 and you get a positive 3x. Okay. Now let's look at example number 3. Example number 3 is 2 binomials being multiplied together. So you want to look at this x first. This x needs to be multiplied by everything in the second parenthesis, and this 7 has to be multiplied by everything in the second parenthesis. So let's start with the x. Let's do x times x. Well, x times x is x squared. Now let's do x times 8. That should give you a positive 8x. Now, like we said, we're going to take the 7 and multiply it by x, and we get 7x. We take this 7 and multiply it by 8, and we get a positive 56. Now, looking at this polynomial here, are there any like terms? Well, you should be saying, I have 8x and 7x. If you add those together, you get 15x. And now you can just bring down the x squared and the 56. Okay, these 3 examples that I just did was the traditional way of distributing. Now this box method or tabular method is something that you should have learned in 8th grade. It's the same way to do the same problem. Basically, right now I'm giving you 2 options to do each problem. You may pick one and use whichever one makes most sense to you. So what we're going to do is we're going to represent this product, 3x squared by 9x to the third plus 2x, as a rectangle. So we're going to draw in a rectangle. And if you put 3x here, 3x squared rather, and you put 9x to the third here and 2x here, and you put the plus sign in the middle, aren't you really doing 3x times 9x to the third plus 2x? Length times width is your area that will give you this whole thing. So we can actually separate wherever there's a plus sign, just put a separation. And now you're going to multiply this 3x squared by this 9x to the third and this 3x squared by 2x. So just like we did before, what's 3x squared times 9x to the third? You should tell me 27x to the fifth. And now what is 3x squared times 2x? You should be telling me 6x to the third. So what we are going to do now is just add them. So we have 27x to the fifth plus 6x to the third. No like terms, so that's your final answer. I personally think when you're just doing the distributive property, distributing like this makes more sense than doing a box method. I can set you up for the box method here for this one. You'd put the 3x here, and you're going to break this up into 3 sections. 9x to the 7th goes here, 2x, and 1. And now your goal is 3x times 9x to the 7th, 3x times 2x, 3x times 1. So 3x times 9x to the 7th is 27x to the 8th. 3x times 2x is 6x squared. And last but not least, 3x times 1 is just 3x. And now we are going to add these three things together. Since there are no like terms, you just write it like this. Okay? Again, you may pick a method, either use the distributing like normal or a box method. Alright, let's do example number 3 using that box method. So now this time, we're going to multiply x plus 7. So what we're going to do is we're going to put an x and a 7 and an x and an 8. So it's like technically a plus 7 and a plus 8. We are going to multiply and separate. So let's separate them into boxes. And now let's do x times x. You should be telling me x squared. Now take this x, multiply it by a positive 8. You should get 8x. Now take 7, multiply it by x. You should get 7x. Take 8 times 7, and you get positive 56. Now what's great about this box method is the diagonals will tell you what are your like terms. Here are my x's. Those are like terms. So your final answer is going to be x squared plus something plus 56. That something is going to be the sum of 7x and 8x. You add them together, you get 15x. So you see how this answer is the same as that. Alright, let's try the next page. Okay, let's try example number 4. I personally think that the box method will be easier for this problem, so I'm going to model it that way. If you'd like to try the distributing way, by all means pause the video, try it, and then watch the box method and see if you get the same thing. So I'm going to set up my box the same way that I have every time. I'm going to put the longer expression, the 2x squared minus x plus 2 on top. You can set it up the other way if you want. So 2x squared minus x and then 2. And then on the vertical side, I'm going to put x squared and 5. So what you're going to do is you're going to take x squared and multiply it by 2x squared and put that here. Then do this times this, put it here. This times this, put it here. This times this here. This times this here. This times this here. Pause the video and multiply. Okay, your answer should be 2x to the 4th, negative x to the 3rd, 2x squared, 10x squared, negative 5x, and 10. Now if you notice, the diagonals aren't exactly matching up. And the reason why they aren't matching up is because this is a trinomial and this is a binomial. If I had made it x squared plus 0x plus 5 and added a third row, the diagonals would have matched up. But that's unnecessary. As long as you just circle the like terms, so we have a 10x squared and a 2x squared. Those are my only like terms. So we start to finalize the answer by taking the highest power, the 2x to the 4th, then the negative x to the 3rd. Now add the 10x and 2x squared, and you should get positive 12x squared. Then bring down the negative 5x and the plus 10. And that should be your final answer. Had you decided to distribute, you would have taken this 2x squared and multiplied it by everything in the second parenthesis. Then you would have taken the negative x and multiplied it by everything in the second parenthesis. And then you would have taken the 2 and multiplied it by everything in the second parenthesis and combined like terms. And your final answer, whichever way you do it, should be this one. Alright, let's try example number 5. Again, I'm going to try the box method. I feel like it's easier. Make it a little bit longer this time because I need 3 on each. Okay, so I'm going to start with x squared, 3x, and 1. X squared, negative 5x, and 2. Okay, pause the video and do your multiplying. Alright, here are your answers. You should be getting x to the 4th, negative 5x to the 3rd, 2x squared, 3x to the 3rd, negative 15x squared, 6x, x squared, negative 5x, and 2. So now let's check out our diagonals. Look at this. All of these are x squareds. It works out nicely. These are x to the thirds. And here are your x's. So you're going to bring down the x to the fourth. Now what's x to the thirds? Let's see. What's 3x to the third plus negative 5x to the third? You should be saying negative 2x to the third. Now please add 1, negative 15, and 2. Your answer should be negative 12. So negative 12x squared. And now take your negative 5 and 6 and add those. And you should get plus x. And then bring down this last guy, which is a 2. And that should be your final answer. Had you decide to double distribute, your double distributing would look like this. X squared times x squared. All of these, all of those, and then the 1. So you'd have to do all of that. Okay, number 6 is a little bit tricky because it's got a lot of variables in it, but I'd like you to try for homework. I do not care which method you choose, but I would honestly suggest you try both so you see that your answers actually match up. All right, you can leave the last page in this packet completely blank, and we'll go over that in class tomorrow. All right, good luck on number 6.